Hello everyone, welcome back to this channel. And now we're going to start the 141st videos. So this video is talking about the stationary points and the nature of those points. So what I mean by nature could be maximum or minimum or stationary, the point inflation, etc. So we're going to do a couple of things like first a derivative and the second derivative. So there will be two different derivatives to talk about. Before I start, just remind everyone, so now because of the channel is growing very fast, if you haven't subscribed the channel, now it's time to do so, so you can access all those videos easily. So you don't have to search for the channel. So you'll get the latest update automatically. So please do so if you haven't done that. All right, now we're going to start doing this question from 2024 New South Wales HEC Maths Advanced. So which means math methods. So in New South Wales called Math Advanced. We here in Queensland is math methods. So let's have a look at the graph. So we need to sketch the graph, but obviously we're going to discuss the nature of the stationary point. So what I'll do is I'm going to first I'm going to talk about the nature of the stationary points first. So we know the if I let fx equal to the function, so at stationary points, we know is first derivative must be equal to 0. All right, so now we do first the derivative. So I'm going to factorize into two factors. So first, so we decided x1 is 0, the other one is 3/2. So now we check the stationary points in nature. So we need to do double derivative. So decide whether it's concave up or concave down. So it's called concavity. So concavity is determined by the second derivative. So we're going to do second derivative. Let's try factorize. Then we decide it into two x's. One is 0, which is already same as the first one. The second one is a 1. So now we have two stationary points. One, because the first derivative equal to 1 or 0, we can get two stationary points. So that's number 1 and number 2. And also we have two suspect point inflections. Why suspect? Because we don't know whether they are or not. We have to do one more step to test the concavity from those points, left and right. So at the moment, we are suspect them are pointer inflections. So how do we know whether it's a P or I or not? So we're going to do, actually, we tested this one, 3 divided by 2 is the stationary. So we're going to test because it's not, second derivative is not equal to 0. So we will try to test that one first. So therefore, we tested that it's a positive. If you substitute second derivative 3/2, you will get positive value for the second derivative. So therefore, this graph at this point is concave up. So concave up means the minimum stationary point. So that's the first one we decided. Now we're going to decide as two suspected POI. Let's do first one. How do we try to understand whether it's a concave up or concave down. Or so concavity is on the left and the right hand side to determine whether it's a POI or not. So we draw a table. We put a first suspect point x 0. We put a -1 on the left hand side. Now we don't put a 1 on the right hand side, because if it's a 1, we come up this, because we got another point is x equal to 1. It also calls double derivative equal to 0. So we choose half. So you can see easily to decide when the x equal to -1, double derivative is a positive value. So you can always, just for estimate, you don't have to work it out. So just for observation. So 0 in the middle and negative on the right. So therefore, on the left, if it's a positive, concave up. If a negative, concave down. So concavity is change from left to right. So therefore, and also we know this is first the derivative is equal to 0. So also stationary. So not only P or I, also stationary. So that means this particular point 0 and 2 is horizontal POI, because it's not only stationary but also POI. So we call horizontal. The second one, we try number 2. So x is 1. So we try left is a half. On the right, I choose 2. So you can easily observe half is a negative. We'll write down the first instance. And when you substitute 2 into second derivative, you will be positive. So this time concavity also change, because 1 negative, 1 positive from concave up, concave down, and to concave up. But that one, first the derivative does not equal to 0 when the x equal to 1. So that means it's not a stationary. So therefore, this will be non-horizontal for POI. So therefore, my graph, if I draw the graph, because of time, maybe just sketch the graph quickly. Sorry, I'm going to go start doing the coordinates. Then you can actually, because of time, I'm going to just put that graph in so that you can see what to look like the graph. So that's the eventual graph will be. So this is my original fx. So we suspect that there is a 1 minimum, so that's minimum stationary point, and there's this the 0 and 2 is this POI horizontal, and that the one is POI, but it's non-horizontal, because that's gradient does not equal to 0. So that's gradient equal to 0. So there's 3 points, 2 stationary, 1 POI, actually 2 POIs, but they are all different nature. So that's how you draw the graph using those key points. All right, hopefully you are understanding these solutions. And if you do, please give us the thumbs up, and I'll see you next video. Thank you for watching. Bye.